And welcome to Algebra 2 tutorial. In this video, we're going to take a look at solving equations that have either exponential parts to them or logarithmic parts to them. We've been studying these properties a lot. We've been working with these types of functions. We now know enough to put them into equations and then solve for x. So here are three parts that we're going to break this up into. We're first going to do exponentials. Then we're going to have equations with logarithms in them, and then the natural log, which we've talked a little bit about, but not much. So we're really going to dive into that a little bit more here. So first, exponential equations. So here we have two good examples here where we have an equation, and in that equation there is an exponent, and the x is up in that exponent. So we've got to get the x out of the exponent, and that's going to be our main topic for today. How do we get that out? So first though, we're going to get rid of other stuff. I can get rid of this minus 10 like we always do. It's not touching the exponential at all, so we can just add 10 to both sides. That works like regular. So we're left with 4 to the power of 2x minus 5 is equal to 64. All right, so now the only thing that's left is this exponential. We've got to do some special stuff to get rid of it. And the special thing we're going to do is a log. So remember, we defined log to be the opposite of an exponential. And to get rid of a log base 4, or sorry, an exponential with a base of 4, we do a log base 4. That is going to cancel that out. And the only thing that's left is the 2x minus 5. Now, what happens on the other side? Well, if we log 4 one side, we have to log base for the other side as well. Now this whole thing is just a number. So what is log base 4 of 64? Now we can't type that into the calculator just the way we want to, but we can get the calculator to do it. So there's no log 4 on the calculator, but there is a log base 10 right here. So we'll do log of 64. But then to turn that into a log base 4, we use that base change property, which we looked at last time. So we're going to divide that by log of 4. So that's just the base change property to let us do this logarithm here. And that is just going to be a number. It happens to be exactly 3. So this will be 3. And this is a nice, easy equation. We can just rock it through this. So we get 2x is equal to 8 divided by 2, x is equal to 4. So our big new thing here is to get rid of that exponential statement, we have to log base 4 on both sides. That will get rid of the 4. All right, let's take a look at our second example here. So here you see we have an exponential on both sides of the equation. And both exponentials have an x in them, and we want to get x by itself. And so here, that choosing the log 4 got rid of the only exponential, but now we've got 2. So yes, we are going to log both sides, but which one do we pick? 7 to get rid of the 7, or 5 to get rid of the 5? Well, we're in luck. It doesn't matter. You can choose to do either the 7 or the 5. It doesn't really matter. Both will actually get rid of the exponential for you. So I'm going to pick 7 this time, but again, it doesn't really matter. So what happens here is we're going to use a property that we learned. So yes, I can cross out the log 7 of 7. But what I really want us to focus on is the fact that this exponent gets brought down to the front. That was one of our properties. If you have a log statement and it has an exponent, you can bring down the exponent to the front of the log. So this is actually x minus 3 times log 7 of 7 is equal to, now the same thing is going to happen over here, but because it's kind of scrunched up, I'm going to write it all out one more time. Log base 7 of 5 to the x. Now, this part, log base 7 of 7, does cancel out. That is just 1. We define log base 7 to cancel out that 7. So we're left with x plus, what am I saying? Minus 3 is equal to, now we're going to do the same thing on this side. So because we have a log statement and it has an exponent, this exponent can come down in front. So the x comes down in front. We have log base 7 of 5. Now here they don't cancel out. This is a number. And we just got to figure out what that number is. Again, we have to use the base change property. So it will be log 5. Oops. Divided by log 7. So again, that's just the base change property, and that will just be a number. It is 0.827. So now we've got x minus 3 on one side. I'll put that in a different color here for us. X minus 3 on one side. On the other, we have 0.827x. So this just became the number 0.827. And so now we just have to solve this. Let's see, we should probably minus x to both sides. That goes away. We've got negative 3 is equal to, these are like terms, and so we have to combine a negative 1 and a 0.827. So that is just 0.827 minus 1, which is negative 0.173. Gonna have to get used to some decimals with these. These problems rarely work out nicely like the first one did. And then to get x by itself, just divide both sides. And so we will do a negative 3 divided by negative 0.1. Oops. 173. All right, so we do that division and we get 17.341. So I know that's a lot of steps. Where are the most important steps? Well, the first one is really important, where we logged both sides. And it doesn't matter what kind of log you choose. Then the exponents get brought down. That was another important step. And from there, I'm hoping you're home free. Yes, you got to remember the base change to turn that into a number, but then it's just numbers and x's, and you solve the equation like you always do. All right. So now let's actually apply this to a word problem that we're very familiar with. So you have a credit card debt of $3,500 and it's earning 12% interest compounded monthly. How long will it take for this debt to reach $4,000? So you remember, we have our compound interest formula. Here's what we start with. 1 plus our interest rate, which is 12%. Now our number of compoundings, because it does say compounded monthly, we know that's a 12. Raised to the power of 12. Now we don't know the time. How long will this take? T. And what do we want to get up to? We want to get up to $4,000. So that will actually be this one over here, the y value essentially. So here we have an equation, and the exponent has our variable. And so we have to solve this equation to figure out how long does that take. And so first we're going to get rid of everything outside the exponential. We can divide both sides by 3,500. So we've got 4,000 divided by 3,500. 1.143, let's say, is equal to, now what is left over? Now I'm noticing that inside the parentheses, we only have numbers. 1 plus 0.12 divided by 12. That's just a number, and I can type that into the calculator as well. So 1 plus 0.12 divided by 12. Let's turn those parentheses into just number 1.01. All right, And so here we have just a regular exponential equation. Hopefully this is looking a little bit familiar to what we did in the previous problems. So we have to get rid of this exponential, which means we have to log both sides. Log both sides. Now I'm actually going to do this a little bit differently. If you remember on the previous problem, it didn't matter what type of log we were using. So I'm actually just going to use the log that's on the calculator, log base 10, because I can type that in really easily. So on the left, I need the log of 1.143, which gives me 0.058. And then on this side, the exponent is going to come down to the front, because that's our property of exponents, times log of 1.01. And again, I can just do this on the calculator, and because I chose the easy log, I don't really need to do the base change. It's 0.004. Now I'm going to skip a step because it's taking a little while. What am I going to do here? Well, I'm going to divide both sides by this number right here, which is 0.0043. And these two are going to cancel out. But of course, if I divide one side, I have to divide the other. So what's left over? 12t is equal to whatever that is right there. So 0.058 divided by 0.0043. 13.488. 13.488, and divide both sides by 12. Is 1.12. All right. And remember, credit card and all this stuff is measured in years. So if you don't pay off that debt for just over a year, 1.124 years, it will then be worth $4,000. And if you remember, this was a type of thing that we couldn't do before. We could estimate how long this would take, but we could never find it exactly. Now that we can solve this equation using logs, we can actually find this answer exactly to as many decimal places as we want. So no more estimating there. That's kind of nice. All right. So that was a little long. We just covered exponential equations. Now it's time for a logarithm equation. So if we have an equation that has a log in it, let's take a look at how we do that. So remember, the opposite of a exponential is a log, so the opposite of a log is an exponential. And so we're going to do 3 raised to the power of this side and 3 raised to the power of that side. The 3 and the log 3 cancel out, and you're left with 5x minus 3 is equal to 3 to the 7th on the other side. That's a really big number. So let's do that on the calculator. 3 raised to the power of 7 is 2,187. 2,187. Now, if that looked a little weird to you, there's another way of thinking about this. Remember our definition of log. You could also take 3 to the power of the other side, which is 7, is equal to the inside. And hopefully you can see you would get the same thing. 3 to the power of 7 on one side, that's this number, is equal to the inside, which is 5x minus 3. So either way you think about that, it does work. And I'm hoping you're home free from here. This becomes really easy. 5x is equal to 2,190, it looks like. Divide both sides, 2,190 divided by 5, 438. So there, the only trick is the very beginning is rewriting the log. 3 to the power of 7 is equal to 5x minus 3, or taking 3 and raising it to the power of both sides, they accomplish the same thing. All right, let's do another one. Here we go. This one looks really complicated. It's going to take some properties that we remember from logs. So we got 2 logs here. We eventually want to combine them. Before we do that, though, take a look. There's a 2 outside of this log. And remember, if it's on the outside, we can move it up to become an exponent. So that is log base 5 of x to the power of 2 minus log 5 of 25 is equal to 3. All right, so we first use that property. Then I remember we have a property, if 2 logs are subtracting, we can combine them into 1 log and divide the inside. So x squared over 25 is equal to 3. So we took the 2 logs and combined them into 1 log. And now that I have 1 log, I want to get rid of it. So I'm going to take my base of 5 and raise it to the power of both sides. So this goes away. I'm left with x squared divided by 25 is equal to, and 5 to the 3rd power is 125. And hopefully you're home free now. We're going to multiply by 25 to both sides and then square root. So let's do that. 125 times 5, 25. And then we need to square root that. And we have our answer. X is equal to 55.9. All right, so we used our log properties, the exponent property and the subtraction division property. Once we had that, we could get rid of our single log by doing 5 to the power of both sides, and then you were sort of home free from there. So that's the basis of log. Our last topic for this is going to do the 2 together, but with what's called the natural logarithm. We haven't looked at that enough, and so we need to look at it a little bit more. So the natural logarithm, all it is using that special number e we talked about. That uses the continuously compounded interest formula, and so that e pops up a lot. So we're going to minus 3 to both sides. That goes away. You're left with 130 is equal to 5e to the x minus 1. Again, we have something outside the exponential, so we can get rid of that without any trouble there. So e to the x minus 1 is equal to, let's see, is that 26, I believe? And then we have to get rid of this e. So we're going to have to log both sides. And there's a special kind of log that we're going to do. It's called log base e. All right, because we want to get rid of the e. And it's a popular one. It happens a lot. And so we give it a special name. It's called the natural log. And we just kind of abbreviate it with lowercase ln right here. And you don't have the base e, but the natural log automatically has a base of e. And so it will cancel out the e. We're going to natural log that side as well. And because it's so popular, it is actually on the calculator. If you take a look right underneath the other log, there's just an ln. That stands for the natural log. It's the second log the calculator can do. Remember, this log was a log base 10. This one is a log base e. And it's on the calculator because it's so popular. So we're going to natural log 26. So we don't have to use the base change because it's already pre-programmed. So we get 3.25, and let's call that a 6, round that up, is equal to the natural log and the e cancel out. You get x plus 1. Subtract the 1, x is equal to 2.26. So this ln, this natural log, is the opposite of an e. It's very important. It pops up a lot, which is why it shows up on the calculator. And so that should also help us on this one as well. So here we have two logs again. They are natural logs, but still logs. And so we can use our log property. They're adding, so we can multiply the insides. So the inside will be 10x squared is equal to 4. So if I want to get rid of a natural log, I need to take e to the power of both sides. Remember, e and natural log are now our opposites, so those go away. I'm left with 10x squared is equal to e to the 4th. That is also on the calculator. You do second ln right there. Sorry, you couldn't really see that. Right above the ln is e to the x, and so we can do e to the power of, and we want to the 4th power. And we get 54. 5, 9, 8. And hopefully you're home free from here. We're going to divide by 10 and then square root everything. So divide by 10 and then square root of that number. And our answer becomes 2.33. Or 34 if you want to round it up. All right. So, oops, sorry about that. We've just solved sort of 3 types of equations. If you have an exponential, if you have a logarithm, and then we reviewed the natural logarithm e and ln x, how those are opposites of each other. So let me give you a few practice ones to try out here. Very similar to the ones we just did. Hopefully those make some sense. Good luck.